We're looking at identifying quadratic equation forms. We have two different graphs here. One is in intercept form and one is in vertex form. We set each of these pieces equal to 0. So we have x plus 1 equals 0 and x minus 3 equals 0. So we have intercepts at x equals -1 and x equals 3. Now our axis of symmetry is going to be right in the middle at 1. So the vertex, the first point is going to be a 1. To get the second point, we plug the 1 into the equation. We simplify and we get a -8. So our vertex of this equation is going to be at 1, -8. We draw a smooth curve to make a parabola, and then we go to the vertex form. When we're doing the vertex form easily tells us the vertex. Now this middle part, it's in parentheses, so it has to do with the left-right shift. We have a -1, we do the opposite, which makes it a +1, and then we have down 8. So we're going to have a vertex at 1, -8. Our axis of symmetry is right on top of the vertex. We can use our key points, which is 1, 1, 2, 4, to find the rest of the graph. We have a vertical stretch of 2. So vertical has to do with the y values, which is up and down. We multiply each of these y values by a 2. From our vertex, we go over 1 up 2 and over 2 up 8. We draw a smooth curve, and if you notice, both of these parabolas are exactly the same. All the points line up exactly. So we're going to take each of these and convert them to standard form. On the left, we're going to take our x plus 1 and our x minus 3, and we're going to multiply them out by FOILing. X times x is x squared. X times -3 is -3x. Then we have our 1 times x is plus 1x, and our 1 times -3 is a -3. We're going to combine the like terms together. We take the 2 and we multiply it through using the distributive property of multiplication. And we have our equation in standard form. Now we're going to do the same thing to the second equation. Now, whenever you see the x minus 1 squared, that's the same thing as saying x minus 1 times x minus 1. Let's go ahead and multiply or FOIL this out. X times x is x squared minus x, minus 1x or minus x. Then we multiply this -1 through. We have -1x, and a -1 times a -1 is a +1. We combine those middle-like terms, and we have x squared minus 2x plus 1. We multiply the 2 through, and then at the end, we're going to minus 8. So we have 2x squared minus 4x plus 2 minus 8. And then we have 2x squared minus 4x minus 6. And if you notice, these two equations are exactly the same, which is why we had two graphs that were exactly the same. So we're going to write in here that both equations are the same. Now, if we're trying to find what form the equation is in, we have to ask ourselves 3 questions. Number 1, is there an x squared and an x? If you see an x squared and an x, this is in standard form. Question number 2, is there an x and an x but no x squared? If there's an x and an x but no x squared, this is an intercept form. And then the third type is anything else is going to be in vertex form. So let's look at number 2. We're going to look at the form here. So is there an x squared and an x? If we look at this, we have an x squared here and an x here. So this is in standard form. Now, for concave up or concave down, we want to look at the a value. If it's positive, it means it's concave up. If it's negative, it means it's concave down. So On standard form, we have ax squared. It's the number in front of the x squared. So we have a -2. So since it's negative, it's going to be pointing down. So this would be concave down. Now, if it's concave down, it's looking like this. It kind of looks like a mountain. And if you had someone up on top of a mountain, they would be at a maximum point. So whenever it's concave down, that's going to go with a maximum point. Let's look at number 3. Is there an x squared and an x? So we look, x squared and an x squared and an x. So this is in standard form. We look at our a value. There's not a sign in front of it, so it's a positive sign. So remember, if it's positive, it makes a happy smiling face. So it's going up, it's concave up. Now, if it's pointing up, it's kind of like you're in the bottom of a pit. Okay, so if you're down in a pit, you're at a minimum point. You're at the lowest point. So this would be a minimum. So looking at 4, we want to look at our questions. Is there an x squared and an x? Now, if you look here, I don't have any squareds on this one. So this is not standard form. Question 2, is there an x and an x, but no x squared? We have an x and an x here. There's no x squared term like there was over here. So this is going to be an intercept form. Now, you want to look at the sign in front. So there's not a sign. So if there's not a sign, it's a positive. So it's a positive number. And remember, if you have a positive, you're happy. So this is pointing up. And whenever you're pointing up, it's like you're down in the pit. You're at a minimum point. This will be a minimum. On number 5, we're looking, is there an x squared and an x? Now, I only see one place where the x shows up. So there's not an x squared and an x. There's not an x and an x because there's only one x. So anything else is in this vertex form. Now, again, you want to look in the front. If there's not a negative sign, it's a positive there. And positive signs are pointing up. So it's concave up. And whenever you have concave up, it's also a minimum point. Number 6, there's not an x squared and an x. There's not an x and an x. There's only one place that the x shows up. So this is anything else. This is in vertex form. There's a negative in the front. So negative, make a frowny face. So it's going to be opening down. And anytime you're opening down, it's like you're on top of a mountain. So this is going to be a maximum point. Okay, so 7, we want to look, is there an x squared and an x? Now, I don't see any squareds, but there is an x and an x with no x squared. So this is an intercept form. If there's not a negative, it's a positive. So positive signs go concave up. And you have a little pit, so you're at the bottom of a pit, you're at a minimum point. Now, whenever you see an x squared and an x, you know that you're going to be in standard form. You have a negative in your A spot. Negatives point down. And whenever you're pointing down, you would have it looks like a mountain, so you're at a maximum point. Now we have an x squared, but we don't have an x to go along with it, so it's not standard form. You don't have an x and an x. There's no x squared in intercept form, so anything else is in vertex form. So this one's in vertex form. It has a negative in the front. Negatives point down. And you have a maximum point because it looks like a mountain. Number 10, there's not an x squared and an x, but there is an x and an x. So this is going to be in intercept form. It has a negative in the front. Negatives make a frowny face going down. And they also have a maximum. Okay, so we're looking at these next ones. These are all mixed up. So we have had lots of different forms looking at them for the last few sections, but today they're all mixed up. So first we want to figure out what form it's in. So we're looking at this. We have an x squared and an x. This is going to be in standard form. When you're in standard form, you want to write down your a, your b, and your c. Your a value is 1/2. Your b value is a -4. Now, if you look, we don't have a c value. There's not a number at the end by itself. So what we can do is we can just tack on a 0. So we're going to have a 0 here. So then we're going to go ahead and use the equation x equals -b divided by 2a. And this will give us our axis of symmetry. Axis of symmetry. So our b is a -4. So we have a -4, which is going to make a +4, divided by 2 times our a, which is 1/2. This equals 4 divided by 2, half of 2 is 1, which equals 4. So we're going to have an axis of symmetry at 4. Now to find the vertex is we always just take our axis of symmetry as the first point, and then we plug that 4 into the equation. We're going to take this 4 and plug it into this equation up here to find the y value. So we have 1/2 times 4 squared minus 4 times 4. This equals 16 times 1/2 minus 16, which is 8 minus 16, which equals a -8. So -8 is going to be our second value here. So we go ahead and graph our vertex over 4 down 8. And then we can use our third point. We can get the y-intercept by using 0, c. Now our c value is 0, so we have 0, 0. We put that point on, and then we use we reflect it over the axis of symmetry to put our second point. And then we connect those into a smooth curve. For the second graph, we're going to take, we don't have an x squared and an x, but we have an x and an x. There's no x squareds. This is going to be an intercept form. When using intercept form, what we're going to do is we're going to set each of these equal to 0. We have x equals 0 and x minus 4 equals 0. X is already solved for in the first equation, but to solve for it in the second equation, we add 4 to both sides. So x equals 0 and x equals 4. Our axis of symmetry is right in the center at 2. And then we're going to go ahead and plug it into the equation. We take our 2 and plug it in. So we have our equation is x times x minus 4. We plug a 2 in, and that gives us a -4. Then we connect the parabola into a smooth curve. Okay, for the last form, we look, is there an x squared and an x? No, we have an x squared but not an x. Is there an x and an x but no x squared? No, this has an x squared. So anything else is going to be in vertex form. So this very easily tells us the vertex. Now normally it looks something like, the equation looks like this. And our vertex is at HK. Now if you look in here, there is not any number with that x. So if there's not a number, that means it didn't shift left or right at all. The only thing it did was went up 7. So we're going to start at 0, 0, and then go up 7. And we put our vertex right there. Now for vertex form, we want to use our key points, which are 1, 1, 2, 4. And then we're going to multiply by our a value, which is -3. So we multiply 1 by -3. And 4 by -3 gives us -12. And so from that vertex, we start here, we go over 1, down 3, and then we're going to put a point right there. Our second point, we count over 2, but down 12. We reflect those over the axis of symmetry and draw to connect into a smooth curve.